Hey guys, welcome to Unit 5, Lesson 4. Today we are talking about odd and even functions. So these types of functions have symmetry, and we're going to start out talking about even functions, which is this graph here. This is an example of an even function, and they are symmetric across the y-axis, which is this vertical axis right here. So if you see a function that looks like it's sort of reflected across that y-axis, that's a pretty good indication that it is an even function. But I'm going to show you here that you want to double check with the values on the graph. So if f of x equals f of negative x for all values of x, that's the true definition of an even function. So for example, if I'm labeling this point that the graph sort of comes to a crescent as -2, and then on the right side as +2, then that would mean for this function to be even, these points at the top here would have to equal the same y value, so I'm going to call that 3. So that means f of x equals f of negative x for all values of x. So that would be true for every point on this graph. And I'm going to show you another point on this graph as well. You'll see where the graph hits the x-axis on the left, and I'm going to call that -3, the x value -3, and then 3 on the right-hand side. And we know that the y value for both of these points is 0. So that is an even function. Now I'm going to show you an odd function. So odd functions are symmetric when reflected across the x and y axes, all right? Which is another way of saying that they're rotated 180 degrees. So that's a full upside down flip, which I'm going to show you now. Keep in mind what this graph looks like, and then it looks exactly the same when I flip it over to the other side, right? All right. So that's a good way to test if a function is odd. The definition here is f of x equals negative f of x for all values of x. So over here I'm going to call this point on the x-axis -2, and I'm going to call this 2 on the right-hand side. And then you can tell this is an odd function if the y value, I'm going to call it 5 on the positive side and -5 on the negative side, if these are the same number, but one is negative and one is positive. And if I write out the coordinates of these 2 points I've just plotted on this graph, I get -2, 5 and 2, -5. So that is an example of an odd function. And this last graph is an example of a function that is neither even nor odd. So I'm going to check first if it's an even function. So this one's not symmetric across the y-axis, right, which is this vertical axis. You can tell easily here because it has this dip on the left-hand side and there's no dip on the right-hand side. So that is not symmetric if you reflect it across the y-axis. And it is not symmetric when rotated 180 degrees, as you can tell when I flip it over. It sort of has this peak at the top instead of having the valley at the bottom. So it's a totally different graph when it's rotated. So we know this function is neither even nor odd. So f of x does not equal negative x, and f of x does not equal negative f of negative x. You can usually tell pretty easily if it's neither because there's not any symmetry going on in the graph. So after this lesson, you should be able to identify even and odd functions by their graph, which we went over. And you recognize an even function by these symbols here, and recognize an odd function by these symbols here. All right, great job today.